Okay, let's dive right into this explainer and demystify the vast and, honestly, sometimes overwhelming world of data. Today, we're going to look at how information is fundamentally organized, because understanding the structure of your data, well, that's absolutely key to unlocking its real value. Just look at that number, 2.5 quintillion, with a staggering 2.5 quintillion bytes of data generated across the globe every single day. Managing all this information is literally the ultimate modern challenge. I mean, from simple text messages to massive corporate financial databases, we are practically drowning in information. But here's the thing, not all of this data is created equal, and how we handle it depends entirely on how it's built. So, to make sense of this massive scale, we've got to anchor ourselves to a core concept, and that is the data model. You can kind of think of the data model as the ultimate measuring stick for how rigid or chaotic our data truly is. By definition, a data model is simply a specification for the elements of data contained within a data asset. Basically, it defines exactly what belongs where. And as we're going to see, your relationship with the data model literally changes everything. Here is our quick roadmap for today. 1. Meet the data model. 2. Structured data, perfect order. 3. Unstructured data, absolute chaos. 4. Semi-structured data, the bridge. And finally, number 5, why data types matter. All right, section 1, meet the data model. And moving right along to section 2, structured data, perfect order. Remember that invisible framework we just talked about? It dictates how information is stored, processed, and analyzed. Historically, this was totally non-negotiable. You had to define exactly what your information looked like before saving a single byte. And that brings us to structured data. Think of structured data as a perfectly labeled filing cabinet. It relies entirely on a strict, detailed physical data model that dictates exactly how every single piece of information has to be represented. Before anything is stored or retrieved, you have to define a schema. So if a field is meant to hold a customer's first name, there is absolutely no way it can contain a birth date or a driver's license number. The data model acts like an uncompromising bouncer at the door, just checking every value to make sure it follows the rules. You can see how traditional relational SQL databases organize this structured data. The information is meticulously divided into well-defined, super rigid tables with columns and rows, and they reference each other through foreign keys. It's highly organized, it's incredibly fast for complex querying, and it completely guarantees consistency. But to pull that off, it relies 100% on that strict data model. Because of this rigid dependency, structured data is the absolute perfect fit for organized, quantitative assets. We're talking about things like CRM databases, financial records, customer names, billing info. When you really need to quickly read large data sets and ensure absolute accuracy, like, say, calculating quarterly revenue, structured data and its strict model are exactly what you want. Okay, let's flip things around. Section 3, unstructured data, absolute chaos. Flinging ourselves to the complete opposite ends of the spectrum, unstructured data just completely abandons the data model. There is no model. It lacks any detailed, meaningful structure for a business domain, no rows, no columns, no predefined rules dictating what the data has to look like. It's just stored in its raw, natural format. And because it doesn't have that formal data model, it presents the absolute biggest challenge to data classification and management. To really picture this, if structured data is our perfect filing cabinet, unstructured data is just a massive pile of random papers, photographs, and objects dumped in the center of a room. You know for a fact there's valuable information in that pile somewhere, but you can't just run a simple query to find it. Pulling insights out of this chaos requires some really heavy, specialized preprocessing, things like natural language processing or image recognition tools, just to extract any kind of meaning. And here's the crazy part. Most real-time data streams actually fall into this chaotic category. This includes everything from your emails and video files to PDFs, raw IoT sensor data, and social media posts. A really fascinating example comes from clinical trial research. While structured data might give you a patient's lab values, it's actually the unstructured data, the free text clinical narratives and physician notes, that captures the crucial context of a patient's prognosis. It is incredibly rich in insight, but man, it is incredibly complex to analyze. So how do we compromise? Section 4, semi-structured data, the bridge.
To resolve that intense tension between perfect order and absolute chaos, we arrive at semi-structured data. Acting as the ultimate bridge, this data type uses a self-describing model. You can think of it kind of like self-labeling moving boxes. It uses internal tags or markers to separate elements and build a hierarchy, but it doesn't enforce the rigid, predefined rules of a traditional database table. It has structure, sure, but that structure is totally flexible and travels right alongside the data itself.
Notice how this contrasts with those rigid SQL tables we saw earlier. No SQL databases actually thrive on this flexibility. Instead of forcing your data into strict rows and columns, no SQL uses graph, document, and key value pairs to store semi-structured data dynamically. You don't have to define a massive schema upfront. If you suddenly need to add a new attribute to a record, you just add it. The database adapts instantly. It's a real game changer. Formats like JSON and XML are the undisputed standards of the modern web for this exact reason. They allow for rapid, agile software development because they can literally evolve their data model on the fly. Every single time your web browser renders a page or an app talks to an API, that data is flying back and forth in a semi-structured format like JSON. It's perfectly readable by both humans and machines, and it handles complex nesting without needing those cumbersome table joins. All right, wrapping up with section 5, why data types matter. So we've mapped the spectrum, but why does all this actually matter? How do these varying relationships with the data model dictate our business decisions? Well, just look at the shredding problem. While the flexible, self-describing model of JSON is an absolute dream for software engineers building web apps, it historically creates an analytical nightmare. Data warehouses are built to read flat, structured columns. So, when data engineers face deeply nested JSON data, they have to build these brutal pipelines to shred or flatten that information into a strict model before analysts can even query it. So yeah, your choice of data structure directly impacts the sheer engineering effort required to actually gain insights. Let's put this into perspective with a crystal clear takeaway. Structured data relies on a strict physical model. Think of your CRM databases. Unstructured data has no formal model, like your video files, and semi-structured data uses a self-describing model, like JSON or XML. The rigidity of the data model is literally what fundamentally separates how we store, manage, and extract value from these assets. As we wrap up this explainer, I want to leave you with a bit of a provocative thought. We are entering an era where AI thrives by ingesting massive, petabyte-scale volumes of unstructured, modelless data. We're talking raw text, images, the whole shebang. With advanced data lakes and AI's ability to parse all this chaos without needing a predefined schema, we kind of have to ask ourselves, are the days of the traditional, rigid data model finally coming to an end? Or will there always be a need for the perfect order of rows and columns? Thank you so much for exploring the data model spectrum with me today, and keep questioning the data around you.